Okay, in the last class we were discussing about the forward bias and reverse bias of a junction diode. This is the VI characteristic of a diode. When I see this is a diode P and N. If P is connected to positive and N is connected to negative, then the diode is said to be in forward bias. This is there in your practical also. So ammeter is connected in series, voltmeter is connected in parallel. And when we increase the voltage, we don't increase like 0, 1, 2, 3, 4. In forward bias, we have to increase only with a point difference 0, 0 0.1, 0 0.2, 0 0.3. So for that reason, in the settings of the board, now we have ready-made board. Earlier we did not have boards. Now they have a ready-made board. Just we need to increase the ammeter, voltmeter, everything is fixed on the board. Just to connect the ports and start working on that. So in forward bias, we change with the difference is 0.1. See 0.10, it goes in this way. Now in the reverse bias, if P is connected to negative, N is connected to positive. So that is how the reverse bias works with the difference of 1. Okay, so 0, 0.1 up to 1. And in the beginning, the current is showing 0. But after at 0.5, it starts increasing. What is the meaning of this? This is said to be threshold voltage or knee voltage or cut-in voltage. There are three different voltages. So the voltage at which the current starts flowing through the diode means the conduction of diode takes place. That is said to be cut-in voltage or knee voltage or threshold voltage. Now coming to the reverse bias, the increment is like 0, 1, 2, 3, 4 and up to 10. So here we don't go beyond 1, here we don't go beyond 10 in the reverse bias. So what happens if you go beyond that? So the diode will break, the junction will break and it is no more a diode. Now coming to VI characteristic, you can see this particular voltage is said to be the knee voltage. Okay, and so if you want to find out the resistance, just use the slope. Find out the slope of this curve. You can find out the resistance of the graph, resistance of the diode in the forward bias. So there is resistance in the forward as well as backward also. So but in forward it is very less. Okay, forward bias resistance because the junction is very thin, whereas at this I told you at a particular voltage, what happens? The current here, very small current is flowing, that also due to the leakage current or we say reverse saturation current. Now once you come to this region at a particular voltage, more current starts flowing through this one. So that is said to be breakdown voltage. VBR is said to be the breakdown voltage. Okay, now so these are the two important parameters to be learned from this PN junction diode. Next one, we have PN junction diode is used as a rectifier. It is applications are rectifier as well as to block the current to leave the battery. Next, in that rectifier, we have rectifier means which converts AC to DC, which is used in adapters and laptops and chargers. So we have half-wave rectifier, full-wave rectifier, and bridge rectifier. So half-wave rectifier, whatever it is, rectifier converts AC to DC. First, we have to step down the voltage from 230 to 20 or 30 or 10 voltage, very low voltage. Without directly, we cannot convert 230 voltage to DC. That's not possible. So first, we have to bring down the voltage using the transformer, give it to the diode, and it will give the output. So we have half-wave rectifier, full-wave rectifier, and bridge rectifier. Half-wave rectifier, here what is there? This is the this is the AC supply, this is a transformer, a step down transformer, this is the diode, and this is a resistor. So the step down transformer, so number of turns on primary is greater than the number of turns on the secondary, and here RL is said to be load resistor across which the output voltage is measured. Okay, so now if you see carefully here, the input to the, this is the waveform, this is the input and this is the output. Diode only conducts for the positive half cycle, it doesn't conduct for the negative half cycle. So the efficiency of this rectifier, half-wave rectifier, is around 40.6%. Okay, that means if you give input like 100%, like only you will get this much. Okay, because only half of the cycle is taken into consideration. Whereas if you come to full-wave rectifier, okay, full-wave rectifier, again there is a step-down transformer. There are two diodes instead of one diode. There are two diodes with a center tap. What is the purpose of center tap? So it is to change the the signal to 180 degrees. So here there are two diodes, and this is the load resistor on output here. So this is the input given to D1, this is the input given to D2. We change the phase by 180 degrees and give it to D2. What is the purpose of that? If you don't give, what will happen? The thing is, if you if you don't change, then for both the diodes the output will be same. This output will not be there, only this output will be there. So for that reason, what we are doing is we change the phase by 180 degrees and give it to the second diode. So the first diode will be giving this type of output and the second diode will be giving this type of output. When they are superimposed, means actually we are not supposed to show like this. This is the complete output. So we are showing it here independently. What is the output of D1? What is the output of D2? Altogether it is like this. But can we connect this type of signal to the electronic devices? No, answer is no. Why? Because the output should not be in ripples. There should not be any ripples in the diode. Okay, ripples should not be given. Now next one. See, this is the AC input, this is the AC and this is the DC. It should be actually uniform line. So for that purpose, we are using filtering circuit. What is filtering? Either capacitor or inductor is used as a filter. I told you when I was teaching passive components, resistor, capacitor and inductor. Capacitor is used to store electrical energy. It is also used as a filtering circuit, filtering component. Same like in inductor also. Inductor is used to store magnetic energy as well as it is used for filtering purpose. That where we are using in filtering purpose for tube light, we use inductor as a filter. Now coming to this one, this is a capacitor and this is a load resistor. To the output of the full wave rectifier, we connect a capacitor and there is a load resistor across which the voltage is measured taken. Now this is the output of a full wave rectifier. So what we are doing here, when this, if you see carefully here, the pulse is coming down. So what happens when the pulse is going up, the capacitor gets charged, and then when the pulse is coming down, it will discharge. Again it will charge. Again when the pulse is coming down, it will discharge. Charge, again discharge, charge, discharge. So that is how the output of the capacitor works. Now special purpose PN junction diode. Is it clear? This is almost all makes a straight line. So that is how you can connect it to the circuits. Clear? Now I was telling about the branded chargers. See, when you buy a laptop or a mobile phone, you'll have a charger with that. So that is a branded one. So people, what they do is they sometimes they wherever they have some cheap, the actual original adapter is for like little expensive. If you want to buy again if you lost or if something happened to the original one, if you want to buy a new one, you just take it for very less price. But that is not a good one because the filtering is not taking place in that type of adapters. So you should take a good one, branded one. So that is important. Otherwise your phone or the laptop will spoil. Now coming to Zener diode, special purpose PN junction diode is in a Zener diode. A Zener diode looks like this. This is a symbol of Zener diode. And what happens? It is a heavily doped junction diode. Very high doping is there. And also depletion region is very less than. The region becomes very thin. It's less than 10 power minus 6, means less than 1 micrometer. PN junction diode is more than 1 micrometer. And electric field is around very high, 5 into 10 to the power of 6 volt per meter. This much is the voltage developed. Now coming to VI characteristic of a junction diode. So here what happens here? So as the voltage is increasing, current is also increasing. But we are not interested in this one. We are interested in the reverse bias. Why? Because I want to use this Zener diode as a voltage regulator. Regulator means which will regulate the voltage. What do you mean by regulating? Means suppose in India or somewhere, in most of the countries, like when we say 230, the input given to the refrigerator or TV or washing machine, it should be 230 to 240, not more than that, not less than that. But what happens, the input sometimes is beyond 450, 440, sorry, to 240, 250, 260, or sometimes less than that also. If it is less than, not a problem. But if it is more than, then what happens, the component may damage or the device will damage. So it will spoil. So for that reason, we need a uniform input to the devices. So for that purpose, we use a regulator. Okay, we used to have a regulator, but now it is coming inbuilt. Earlier people used to buy that. Suppose if it is example, if your refrigerator is for 1000 dirhams, then earlier we used to buy for 50 or 100 dirham. We used to buy a stabilizer with that. But now it is not required. Now it is coming inbuilt. So what happens exactly? Even though the voltage is changing, current remains constant. Okay, current remains constant for every time. So that is the meaning of the Zener breakdown, uniform break. So how it works? See here, this is a potential divider. What is the purpose of potential divider? The purpose of potential divider is to divide the voltage. Suppose I have 5 volt input and my LED is there. Suppose example I have a LED which only requires only 2 volts. If I give 5 volts, it will damage. So for that purpose, but I don't have, I cannot bring again 5 volt battery, 6 volt battery, 3 volt battery. I cannot bring it. I think that I have one more thing which requires only 3 volts. I cannot bring so many batteries or so many power circuits. So for that, I'm dividing the voltage into 2 parts. How? Using a potential divider. So I keep 2 different resistors of 2 different values. So across the first resistor, I get 2 volt. Across the second resistor, I get 3 volt. So this is sufficient for me. Here also, here I want a I want to fix the power supply voltage regulator. What I am doing, instead of the second resistor, I am using a diode here. What if, so you can do it like this also? No, yeah, you can do it, but the problem is when the input 230 is changing, it will not remain 5 voltage, it will become 5.1, 5.2, 5.3. See, if my input is not, instead of 230, if it is 250, so it may not show 5 voltage, it will show 5.2, 5.3. So automatically, you know, there's a possibility that the circuit may spoil. So for that reason, I want only uniform output. Perfect means, like for mobile phones, I need only 5.1 means 5.1. I cannot give more than that. If I give more than that, my battery will damage. So for that purpose, I'm using a Zener diode here. Zener diode, what it is doing, it will give a sharp cutoff. Okay. So in one of the arm, there are 2 arms. In one of the arm, I'm giving a Zener diode, and across that there is a load resistor, and we measure the current. Understood? So that is how the Zener diode works. Clear? Now we are going for the next 3 more diodes. 1 second. So I am going with 3 different optoelectronic junction devices. Optoelectronic junction devices. In that optoelectronic devices means we are using photo excitation. When I say optoelectronic devices, when the voltage is developed across the diode, then what happens? The photons are generated. I mean, photons are generated. Photons are or photon excitation takes place. Photo excitation takes place. Okay, so these are all said to be the optoelectronic devices. Now, in the optoelectronic devices, the first one is what? The first one is photodiode. The second one is LED, light emitting diode. LED light emitting diode. The third one is photovoltaic devices. That is said to be solar cell. Okay, so we have photodiode, and we have LED, that is said to be light emitting diode, and we have photovoltaic device, that is solar cell. So it is used for detecting optical signals. This is to detect. This is used. I'll write it separately. Wait. Photodiode. It is used for detecting optical signals. Or it is also used as a photo detector. Okay, now I will tell you what is a photo detector. Example, suppose you are using optical OFC. OFC means I am using optical fiber communication. Simple example. Optical fiber communication. In optical fiber communication, we use optical fiber. You know that the Tesla thing which comes to your home, it has a yellow color cable. You might have seen near the modem. So we have sound energy is being converted. When you speak on the phone, sound energy is converted to electrical energy. That is analog signal. This is converted to electrical energy, that is digital. Okay. After converting it to digital, it is converted to optical energy. Okay, that is electrical to optical energy, and this is transmitted into on the optical fiber, OFC, optical fiber. Is sent on optical fiber. Again, here there is a optical energy is converted to electrical energy, that is digital, and then it is converted to electrical energy analog. Okay, analog, then again it is given as sound energy. This happens in 1 nanosecond, very fast. This whole thing happens in 1 nanosecond. Here we need a source which is converting electrical to optical. Here we need a detector to convert optical to electrical. You understood? Here we need a source, that is what? That is a laser light, or we can use a LED. We can use laser light or LED for that purpose. Like we have to convert electrical to optical. Okay, we have to convert electrical to optical. For that purpose, we use laser light or LED. Here for detector, we use what? Here we have photodiode. We can use photodiode, or we use PIN photodiode. Okay, PIN photodetector. What is this PIN photodetector? PIN photodetector. What is that? P insulated N type. P insulated N type. This is a full form of PIN. This is a full form of, okay, this is not there for you. Only we are only discussing about this photodiode now. Which what it is doing, it is converting the optical signals into electrical signals. For that purpose, we are using the photodiode. It is used as a detector. Understood now? So now how it works? First we will say construction, then working of construction of photodiode, and then working of the photodiode, and then VA characteristic of the photodiode. These three we will discuss. All the three are very important. Why it is important? Everyone has their own applications. Understood? Every diode has its own application. Now we will see on that. We'll see the photodiode first. We'll see the photodiode. Okay. In photodiode, what is happening now here? Now here what is happening here? This is H nu. This is P type, P side, and this is N side. This is ammeter. This is micro ammeter. Very small current flows through this. This is a battery, and this is a resistor. So what we are doing in this circuit, light will fall. Like what is the purpose? To convert light energy into electrical energy. So light will fall on the junction region. Light will fall on the junction region. So it will provide enough energy for electron hole recombination, and when the electrons will flow, when the electrons and holes flow in opposite direction, what will happen? There is a, you can see the flow of current here. You can see the flow of current. Means, sir, you may ask, sir, already you have sir, applied enough potential. No, that potential is not enough to drive. They have given, like suppose we have given only 0.6 example, it needs 0.7 to flow. We have given only 0.6. That 0.1 is provided with these photons. When the light incidents, this is a transparent region actually. When light incidents on the junction region where electrons and holes or minority charge carriers are available, at that time electron hole recombination takes place, and they start flowing. Electrons start flowing from N to P, and holes start flowing from P to N. Due to that, you can see the flow of current here. Understood? Is that clear? Okay, it is only giving sufficient energy. It doesn't mean that electrons are coming inside. No. Are you understanding, sir? It doesn't mean that electrons are entering in our junction. No. Electrons are given sufficient energy so that they can move from one region to another region. That is the meaning of this. So if it gives more than, so here what happens when the photodiode is illuminated with light or photons with energy H nu greater than the energy gap of the semiconductor, electron hole pairs are generated due to the absorption of photons. Okay, so here I will write here electron hole pairs, electron hole pairs electron hole pairs are generated, electron hole pairs are generated due to the absorption of photons. Okay, due to the absorption of photons. Okay, when what is the condition? When the light, okay, when the light or photons of energy, energy h nu, which is greater than energy gap of the semiconductor. Okay, greater than energy of semiconductor. So it is given more than that, then what happens? Electrons will flow. Okay, electron hole pairs are generated by due to the absorption of photons. When the light or photons of energy h nu is greater than energy gap of the semiconductor, then what happens? Then the holes, the electron starts flowing in the diode. Okay, so that is how it works. Is that clear? So and also the magnitude of, here one more point, the magnitude of photocurrent depends upon, the magnitude of photocurrent depends on intensity of incident light. Okay, intensity of incident light. So again you have to go back to the, you know that, right, photoelectric effect. So you have to think about photoelectric effect. When the light of certain frequency is made to incident on the plate, then only photoelectric emission takes place. So this is also such type of thing. Okay, so that is why generally in the laser or LED, whatever the laser we are using, generally mostly it is red in color. So red color, that has more wavelength and less frequency. So automatically what happens when it falls onto this one, then you can what happens, the detector will detect. Not only here, it is also used for detectors in photodiode is also used in your TV. You know, you use the remote. On the remote you have a small LED, but that is in IR region. That LED is in IR region. I want to keep that in the so the IR region means you cannot see that. So when you press some button, automatically the channel in the TV will change. What exactly is happening? There is some signal moving through your remote to the TV. In the TV there is a detector actually. So when you press it, this is the source. The LED which is in your the LED which is there in your remote is a source, and there is a photodiode in the TV. So when you press some button, the photodiode receives the signal and it will change the channel. So that is how it happens. Okay, so don't think that only photodiode is only used as an optical fiber. This is the main thing I have explained. One, the major use, and the second, it is in the TV also. Wherever there is a remote, example in the AC also, like split AC. In the split AC also you have a remote. Just press that temperature thing, automatically the temperature of the AC will change. So there is a, you know, in the remote there is a LED that is to be source, and the, you know, and in your AC or wherever it is, we are using a detector. Understood? So that is how it works. So intensity of incident light. So that is how your LED, your photodiode works. Now we will discuss about the very important, that is VA characteristic of the photodiode. We will discuss about the VA characteristic of the junction. So here we have VI characteristics of photodiode. Okay, so we will discuss about the VA characteristic of the diode. Now here, if you look at this one, Okay, so this is a microammeter, this is milliammeter, this is volt, and this is reverse bias. And this is I1, I2, I3, I4. These are the intensities. Okay. Here I4 is greater than I3, is greater than I2, is greater than I1. Okay. So these are the intensities. I4 is greater than I3, which is greater than I2, and which is greater than I1. So illumination intensity for different. So what is happening here? This works in the reverse bias. See, as the reverse bias voltage is increasing, as that we can think about the intensity. We are giving one particular intensity. So think that we are giving one intensity of light. Then as the voltage is increasing, current is remaining constant. See here, after that current remains constant. Like less, like for this less intensity. More the intensity, you can see more is the current flowing through that one. Is it clear? More is the intensity, more current flow. So I will give you a simple example. What is happening, in our when we did about this HSL connection, we have 12 Mbps, we have 100 Mbps, we have 500 Mbps, like this, different are there. It is complete the intensity, man. Like 1 Mbps, 10 Mbps, and 50 Mbps, 100 Mbps. 1 Mbps intensity is less. The same frequency, we are using the same frequency. Don't worry about the frequency. Red color laser light we are using. So when we are giving maybe 1 Mbps, the intense, this is the current, this is the current we are receiving. Okay, that means DC, I mean DC, not the AC, means it is converting light energy into electrical energy. Same thing, see, when the intensity of the light is increased, so what they do is, when you see these people connecting the optical fiber to the modem, they bring one laser meter, means the light which is received, that is measured in decibels. Okay, we say it is flux meter. Okay, we say flux meter. In flux meter we have in flux meter we measure the intensity of light. It is used for to measure intensity of light. Intensity of light is measured in decibels. Okay, intensity of light which is measured in decibels. Or we also measure it in lux. Okay, lux. So we measure it this one. So what this, suppose your plan is only 1 Mbps, then he will not get the intensity of the laser light, he will reduce. He can give more, but automatically they can change. They can check from the from the office also, from the customer care, and also they can technical end. They can check whether this fellow has given more or less. If it is 12 Mbps, slightly he will increase the intensity. If it is 50 Mbps, he will increase more the intensity. If 100 Mbps, it will be more the intensity will be more. Understood now? So more will be the intensity. So more light. So more electrical signals will be there in that one. Is that clear?